Hi guys, Good Golf here with a brand new video on Fishnet Networking. This time I will be covering remote procedure calls. RPCs are an easy way to communicate between the server and client instances of the same object. I will be demonstrating 3 use cases in today's video, and as usual the code will be posted in my GitHub repo. Since the code samples are from a proof of concept game which is showing in the background, you can only use the scripts for inspiration, but some parts of it require third-party components I obviously cannot share. Okay, what are these 3 use cases I want to show? Number 1. The player casts a spell. After pressing a key, the client sends a message to the server which instantiates the network spell prefab. This could be your fire your weapon use case. The player walks to a door and a trigger collider event requests the door to change its state to open through a remote procedure call. On the server, this call changes a networked synchronized value. When that value gets synced with the clients, they play the animation to open the door. This could be a interact with the environment use case. The third use case is inspired by a question asked by Matthew in the part 14 video. When the clients are logging into the server, we want to associate their network connection with their Steam lobby entry. You can accomplish this by adding a remote procedure call to the player script and passing the active Steam user ID and network connection. Let's consider this a game player administration use case. Okay, let's look at each case one by one. Casting a spell or firing some sort of a weapon. In my player script I hard-coded the check if keys are pressed in the update function running on the client. Normally you would do that in your central input manager solution. When the one key is pressed, I call a remote procedure call RPC cast spell. This method has the server RPC attribute, the one between the square brackets, and basically this allows a client to run logic on the server. So, all code within this method runs on the server, which allows you to, for example, instantiate a network-enabled object representing the spell being cast, or a projectile from your weapon. This is what step 2 in my code does. Based on the parameter spell index, the spell details have been retrieved, and one of its properties is the prefab which needs to be spawned on all clients to make the spell visible. The owner of the spell will be the player who pressed the key. We can do that through using the network connection, which was also passed as a parameter to the RPC. Let's take a look at how it works in the game. Next is the animated door. There are 2 scripts I created to make this work. First of all, we have the networked trigger door controller, which implements the onTriggerEnter event for the collider. When a player enters the trigger, it will first check the status of the door, open or closed. It reads the network door synchronized variable isDoorOpen through the getIsDoorOpen function. If the door is closed and this script has been assigned to open the door, then it sends a RPC request door change state with the parameter true to the network door. If we look at the network door, you can see this RPC effectively only writes this parameter into the network synchronized variable isDoorOpen. When that happens, the instances of this network door on each client connected to the server get this new value synced. Through the syncVars onChange event, we trigger the animation and the door will open for all players. There's one additional note I want to make for this code. Since the networked door is part of the scene, it has no client owner. That's why I added the require ownership equals false statement to the attribute. This allows each client to call the server RPC, not just the owner, which we don't have. The last use case is for collecting data of all players on the server. So, I started by creating a simple class, GamePlayer, which collects the Steam user data and the network connection. The GamePlayer class collects these into a dictionary with the Steam ID as key. We simply add a new player to the dictionary using the addGamePlayer method. In order to collect this data, we will add a RPC call to the player script, since that is always instantiated when a new client connects to the server. In the onStartClient event, when we know this is run for the owner, we simply call the sendPlayerInfo server RPC with the network connection and the local user's Steam ID as parameters. On the server, the RPC collects this data through the GamePlayer class I mentioned earlier. So basically, we now know on the server which network connection belongs to which Steam user. Okay, that's it for today, and I hope this has given you some ideas on how to use remote procedure calls. If you check the Fishnet Networking documentation, you will see there are more flavors and settings of the attributes, so I would suggest give it a spin and see how you can make this work in your game. Thanks for watching this video, and I will be working on the next video in the series. Don't forget to like and subscribe.